So what we're going to be reviewing for this video is density and calculating density, but then also using it as a conversion factor. So if we look at number 1, it says an aluminum engine block has a mass of 12.8 kilograms. The block is placed, so this is an example of water displacement. So it tells me that my initial volume of water is 0.2 liters. Okay? And then when I drop the block into it, it displaces the water and causes the final volume of the water to rise to 4.92 liters. So what this is telling me is initially there was 0.2 liters of water. I dropped the object, which caused the water to rise up to 4.92. So the difference between these two will tell me the volume of the object, because otherwise the volume of the water wouldn't have changed. The water rose to 4.92 because the volume of the object is whatever the difference is between these two volumes. So I need to subtract, and what I get is 4.72 liters. Okay? So that is my volume. I know my mass. I can figure out my density. Now the only issue is it's asking for grams per mil. So notice my mass right now is given in kilograms. So I've got to convert that into grams. So I'm going to do that really quickly here. Got kilograms on bottom to get rid of them, and grams up top. 1 kilogram is 10 to the 3rd grams. So what that tells me is that my mass is 12,880 grams. Okay. Let's figure out my volume. So I know that my volume in liters is 4.72 liters. I need to first convert that into milliliters. So liters on bottom, milliliters on top. 1 mil is 10 to the negative 3rd liters. So this is going to be 4,720 mils. Okay? And now it's asking for density. So I know that the formula for my density is density equals mass divided by volume. Okay? So my mass here is 12,880. My volume is 4,720. Okay? And so the value that I get unrounded is this. Now let's figure out significant figures. Okay, so if you look at your mass that should have 4 sig figs, and it does. Okay, when I subtracted here, remember when you subtract, you should be rounding based on the fewest number of decimal places. Well, both of the volumes that are given to you have 2 decimal places, so the 4.72 stays as it is, and therefore it should have 3 sig figs, which it does. So my final answer should have 3 sig figs. So keep in mind, the 4.72 stayed the same, despite the fact that you were subtracting and looking at how many decimal places it had. Sometimes it won't. But the important thing for you to note is you should not be rounding your answer until the very end. If you need to keep track of how many sig figs it should have, and if that number of sig figs is different from what you're writing when you're calculating, that's fine. You just have to keep track of the sig figs, but only round once. Okay? So here I've got 2.73, and my units are grams per mil. Okay? All right, let's look at the next problem. It says a mouthwash is 21.6% alcohol by mass. If each bottle contains 0.358 pints of mouthwash with a density of 0.876 grams per mil, how many kilograms of alcohol are in 180 bottles? Now, obviously, I'm going to break this down for you, and we're going to work through the entire problem. Okay? I'm not going to expect you to answer all of that in one fell swoop. Okay, so if I have 180 bottles, how many pints of mouthwash do I have? Well, it tells me each bottle has 0.358 pints. So one bottle equals 0.358 pints. So what I need to do here is I need to say, okay, if I have 180 bottles, I'm now going to convert that into pints. So I'm going to put bottles on bottom and pints on top. Okay? I know that one bottle has 0.358 pints. of mouthwash. So now I'm just going to multiply 180 by 0.358. And the answer I get is 64.44 pints. Now, I don't really know the answer to this. I'm just going to go based on common sense. This is 180 bottles. You're counting bottles, so you can't use sig figs for that. Okay. I'm going to just go based on 3 sig figs just to play it safe. Now, notice the initial problem is one entire problem. So I wouldn't round normally until the very end. However, since I broke this problem up for you guys, we're going to round at each step. And yeah, that's going to cause a little bit of issues because your answer is going to be a little bit off since you're rounding so much. But just for our own sanity, let's round at 3 sig figs for this problem. I'll make sure it's clear if it's ever unclear like this for a worksheet or a quiz or a test. Okay? Then it says the value calculated into A, which is 64.4, is a volume in pints. The density that's given to you is in grams per mil. What units would you have to convert the pints into? Well, clearly because it's grams per mil, I need to get into milliliters. So I'm going to start with my 64.4 pints, and I need to get that into milliliters, which I can do. I'm going to put pints on bottom and milliliters on top. I know that 1 pint has a volume of 473.176 mils. So 64 times 473.176 mils gives me 30491 mils. So I'm going to round that because I want 3 sig figs. 1, 2, 3. I'm going to round that to 3 sig figs. Okay. Because again, remember you want to keep the 3, the 0, the 4, and the 9 rounds the 4 up. So I've got 30,500 mils. Now I'm going to actually use that volume to figure out the mass in grams. Okay. So I have my volume, that's my given now, 30,500 mils. And it asks me to figure out the grams. So I'm going to put mils on bottom, and I'm going to put grams on top. Now I know that relationship, I know that conversion factor because it tells me above that my density is 0.876 grams per mil. So 0.876 grams for every 1 milliliter. So I'm going to end up multiplying 30,500 by 0.876. And what I get there is unrounded 26,718 grams. Okay, rounded, if I want 3 sig figs, be 26,700 grams because you want to keep those digits and then the 7 stays as it is. Okay, let's look at the next one. It says only 21.6% of the mouthwash is alcohol. What mass of alcohol do you have? Well, I have a total mass of 26,700 grams. Well, I'm going to take the mass, 26,700 grams, and I'm going to multiply that by this percent. But remember, to actually multiply, you've got to put that into decimal form. So you're going to move the decimal 2 places, 1, 2, to make it a decimal. 0.216. Remember, percent means per 100. So that's telling you to divide by 100, which is why we moved it 2 places. Okay? And so when I do that multiplication, I get 5,767.2 grams. I want to round that again to 3 sig figs. 1, 2, 3. So the mass of alcohol I get is 5,770 grams. Okay. My last step is now to convert that into kilograms. So I have 5,770 grams, and I'm going to convert that into kilograms. I'm going to put grams on bottom, kilograms on top. I know that 1 kilogram has 10 to the 3rd grams in it, so I'm going to divide by 1,000. The answer I get is 5.77 kilograms, and that has 3 sig figs. All right, let's look at one last example. I tell you you have 1,100 feet per second, and I ask you how many miles per hour would that be? Now, this is going to be a two-step problem because I need to get feet into miles and I need to get seconds into hours. So I'm going to get out of feet. First of all, let's look at all the conversions I give you. So I want to go from feet to miles. Well, I know the relationship between feet and inches. I know the relationship between inches and centimeters. I know the relationship between centimeters and meters, and I know the relationship between meters and miles. So yes, this is going to be a very long problem. Stick with me. I'm going to get out of feet. I'm first going to go into inches. I'm going to get out of inches. I'm going to go into centimeters. I'm going to go out of centimeters. And we get into meters. I'm going to get out of meters. And go into miles. So remember when I said you really do need to show all your work because you can get a really long problem? This is that example. Okay. Now I'm going to go, if you notice, I'm out of feet, out of inches, out of centimeters, out of meters. I'm in miles per second right now. And so I want to be in miles per hour. So now I got to deal with my unit of time. Notice my unit on bottom for time is seconds. So I'm going to put that on bottom. I'm going to put that on top, seconds. Okay. And then I'm going to be lazy and I'm just going to go directly into hours. And that's because I know that since there's 60 seconds in a minute and 60 minutes in an hour, that means that there are 3,600 seconds in an hour. Now I'm going to plug in all of these relationships. I know that there are 12 inches in a foot. I know that 1 inch is 2.54 centimeters. I'm given that right above. I know that 1 centimeter is 10 to the negative second meters. I'm given that relationship above. I know that 1 mile is 1,609.34. I'm also given that relationship. So I'm going to take 1,100. I'm going to multiply by 12, multiply by 2.54, multiply by 10 to the negative second, divide by 1,609.34, and then multiply by 3,600. And the answer I get unrounded is 750.002. Now keep in mind, because there is no decimal present in 1,100, these zeros are not significant, so I only have 2 sig figs. So I'm going to round this value to 750. My units are now miles per hour. And that's it. Nice, long, challenging problem that is very manageable as long as you're clear with your units and your dimensional analysis.